The function f(x) equals 1 plus x log, or sorry, I'm going to change that to ln. Is that okay? I'm allowed to change that to ln. Why? Log base e is ln, so that you are now going to be converted to ln. Now, I'm going to do the first derivative. I'm thinking I'm just going to use the product rule. I don't like the idea of move. Did anybody try to move that into the power position? Did anybody do ln 1 plus x to the power of 1 plus x? Why is that a bad choice? Never done anything like it before, have we? So, did everybody try and stick with the product rule? No? Product rule, alright. Now, u equals 1 plus x. Du dx equals, we're happy about 1. B equals ln 1 plus x. What's the derivative of ln 1 plus x? Anybody? 1 over 1 plus x. And then you differentiate the part. You just get 1 again, don't you? Alright, that's just the first derivative is equal to the slope. The slope has to equal 0 because it's a turning point. So u times the v dx. Well, that's handy. Plus phi times du dx. Also handy. We're just multiplying it by 1. Handy. And did anybody get it is 1 plus ln 1 plus x? And we get the answer there. Cool. Alright. Equals 0. Why? Because it's a turning point and the slope is 0. I don't know if it's a max or a min. I haven't got a clue what it looks like. Now, we're going to have to solve out what the x value is. What are we expecting the x value to be when it's all said and done? 1 minus e over e. And when we sub that back into the original equation, we're expecting the y value to be minus 1 over e. That's our plan. All right, let's stick to it. All right, ln 1 plus x, or log base e 1 plus x equals minus 1. Now, what did I do with the e? I remember let me see. Log 100 base 10 is 2. Where'd you move the 10 to? Where does the 10 go? If I want to get rid of the log, what do I do? 100 stays where it is, and the 10 moves up and underneath. So you get 100 equals 10 squared. So what do I do here? 1 plus x stays where it is, and e moves up, you get e to the power minus 1. Or 1 over e. Now what happens to the 1? Moves over, and you get 1 e minus 1. Okay? And we need to give it a common denominator. Why do we need to give it a common denominator? Because that's how it's represented in the answer. No bother. What are we going to turn the 1 into? Just e over e, isn't it? Okay, that's what I would do. I just want to give you a second to adjust to that. And I got x equals 1 minus e over e. Who got that far? Oh dear. Slim pickings. Alright. We're going to go back to the original equation. Phelan, call it the original equation for me. Log e 1 plus x, yeah? Now this is not going to be nice, alright? So the first thing I'm going to do is I'm going to break it down to bite-sized pieces. See these two parts here? That's 1 plus whatever x is. So I'm going to go over here and just do 1 plus x in the corner. So it's going to be 1 plus 1 minus e over e. Do you know what I'm thinking? Well, I'll just do e over e. The e's cancel, and what am I left with as my answer? Just 1 over e. So this now becomes 1 over e log e to the power of 1 over e. Alright, that's calculatable in the calculator. Okay, I'm going to throw that into the calculator and hope for the best. I'm not going to throw the full thing in, I'm just going to throw the second part in. I'm going to do ln e 1 over e to the power 1. Let's hope something nice happens. Minus 1. Perfect. So it's 1 over e times minus 1, which is, here's my x, y value. There's the x value, and there's the y value, as predicted. Kill. Alright, that is difficult. Have to determine if it's a maximum or a minimum. Oh, dear God. Alright. Have to find the first derivative. Where's my first derivative gone? Is everybody happy? That's my first derivative. That is my first derivative. 1 plus ln 1 plus x is my first derivative. So the first derivative is 1 plus ln 1 plus x. Now I have to differentiate that again. Charlie, what do you get when you differentiate it? 1 turns to, and then to here, 1 over 1 plus x. And when you differentiate this, what's your second derivative? 1 over x, right? What do I need to replace the x with, Charlie? The x value at that turning point, yeah. Mom's going to put that in. Not the nicest thing you've ever seen in your life, is it? Is there a cheap way out of this? I only need to figure out if it's... Do I have to make it look nice, or do I just simply have to figure out if it's positive or negative? So you'd be entitled to just lobbing it all into the calculator, wouldn't you? And just writing it in decimals. And if it's positive, it's positive. If it's negative, it's negative. Sort of thing. So I'm going to take the easy way out for once in my life and do this. Not make things harder on you. Alright, that's positive to me, which means it's a greater than 0, which makes it a min. Got Oliver? Come on. Alright, how many variables are there? 4 variables. Alright, now the first 2 equations are very easy. That's a y, isn't it? F of x is y. So if the x value is 0, the y value is 4. So what does that mean? 4 equals a times 0 cubed plus b times 0 squared plus c times 0 plus d. This implies d equals 4. Right. There's one answer straight out of the bank. Right. I'm going to do the same thing for 1, 0. What does 1, 0 mean? The y value is 0 when the a value is 1. So a plus 1 cubed plus b times 1 squared plus c times 1, c multiplied by 1, plus the number 4, which is d, equals 0. Everybody code that? Would everybody be happy with a plus b plus c equals minus 4? Okay. Now that's 2 equations using 2 points. Now, I have to listen to what they're telling me. What does it mean by a maximum point? It means the slope is 0 when x equals 0. If it's a maximum point, its slope has to be 0 at that particular x value. So I'm going to do the first derivative, sub in 0 to equal 0. Okay, let's find out. I'll do green writing for this. So first derivative, anybody? Carol, first derivative. Why don't we differentiate ax cubed? 3x squared, yeah. Then 2bx, yeah. B. And what do I have to sub in? So sub in x equals 0. And what's the slope when you sub in 0? What's that mean about our c value? C value is 0. That has consequences over here, where you now just pretend the c value doesn't exist. Okay? Alright, what does it mean by point of inflection? Point of inflection, anybody? Second derivative equals 0. So, there's the first derivative there. Everybody cool with that? What am I going to do with the c value? Well, the c value doesn't exist anyway. So I'm going to differentiate that a second time. What am I going to differentiate it? 6ax plus 2b equals 0 when x is equal to 1. 1, 0. So replace x with 1 and you get 6a times 1 plus 2b equals 0. Now you just simply get 6a plus 2b equals 0. What type of equation do we have? Has anybody solved this property last night? What were your two answers?
2 minus 6.
Everybody cool with that? Are you happy if I don't do the simultaneous equation? Because I think at this, you should be able to put that away now if you get what I'm saying. Just do a simultaneous equation with the two blue equations, finish it off. Yeah, we save our time. Everybody cool with that? Alright. Now, 19. So I'll pause it here. Any questions? Representation. Alright guys. Now. Alright guys. Now guys. G of x equals x squared plus a over x squared. Given that g of x is a turning point at x equals 2, find the value of a. Okay. Turning point means it's either a maximum or a minimum, but we can guarantee that the slope is 0 at x equals 2. Everybody cool with that? Now, once again, I'm feeling a bit tired. I do not want to do the quotient rule, so I'm going to change this to x minus 2. Okay? I'm now going to differentiate the first derivative. I'm going to get 2x into minus 2a x to the minus 3. We all good at that? Now, what happens when I sub in 2 for x? What has to happen? Equals what? 0. So we got 4. I think that's going to be 2a over 8, which is minus a over 4. Oliver, did you get 16? Well, get the out part of your side, cross multiply a equals 16. So show that g of x has no local maximum points. Well, if I prove its only turning point is a minimum point, that means it has no maximum. Would that make sense? So therefore, what should I do? That's the first derivative. So what should I do with the first derivative? Get the second derivative and prove that it's a. Get the second derivative and prove that it's negative when x equals 2. Okay. Second derivative is 2. Minus 3 by minus 2 is plus 6a x to the minus 4. Now we have the a value, don't we? What is the a value? 16. So it's 2 plus 96x minus 4. Now, what's guaranteed about x minus 4? Huh? X minus 4 is always going to be positive no matter what x value you use anyway. Not that even matters. Because you only have to prove that it's positive when x equals 2. Because it says specifically that the turning point takes place at x equals 2. Oh, sorry. I'm wrong. It says it has a turning point. Sorry guys, if we look at the language really clearly, it says it has a turning point. That doesn't take away that it might have another turning point. Does that make sense? No. So what I said earlier, just finding the minimum won't work here. We have to do something else. Okay, now here's what I suggest we do. See this number here? I want to prove that this will never, ever, ever be bigger than. Anybody? I want to prove that it's always bigger than 0. What happens if it's always bigger than 0? If the second derivative is always bigger than 0 for any value of x, it means it's always going to be a min. It can never be a max. So here's what we're going to do. We're going to have 2 plus 96 over x to the power of 4. And what is x to the power of 4? It's x2 to the power of 2, which is a guaranteed positive number. Okay? And if you really want, because it's a guaranteed positive number, you can multiply both sides by it. So you could end up with 2x2 to the power of 2 plus 96 greater than 0. And you say true as x2 to the power of 2 is a perfect square and always positive. Anybody get that? Yeah.
Remember just prove that x, like the only solution of x is 2?
Use the first derivative and show that it's only going to be one answer. Yeah, you could go back. Yeah, I can prove the second derivative will never be negative, which is one way of doing it. Jamie suggested that I come back here and see this. Everybody see this first derivative here? Now, let's see how this will pan out, Jamie, okay? We know that a is what? So, would you raise 32 then, yeah? Okay. And what you're asking me to do is prove that there's only one solution. I don't know if that's going to go as well as we would like. So it's going to be 2x minus 32 over x to the power 3 equals 0, yeah? And then it's going to be 2x to the power of 4. When I get a common denominator, put x3 under everything, yeah? And it's going to be 2 and then an x3 up here. It's going to be 2x4 minus 32 equals 0. Bring it over to the other side, divide by 2. I'm going to get x4 equals 16. Now you might think the only answer is 2, but I'm also aware that minus 2 works as well. So you would have to get the second derivative, sub in minus 2, and prove that it's not a maximum either. It's probably a point of inflection. Is that alright? So your first derivative test would still need the second derivative to outright prove it. Okay? Sorry guys, that's basically nuts and bolts of it. You might need to go over it again. Yeah, and we're done. Alright, next exercise.